Hey everyone, it's meteorologist Aaron Treadway, and here's our first lesson. We're going to start diving into high and low pressure. So this is very basic stuff in the atmosphere, but this is probably one of the most common things that you'll hear on television, hear me talk about whenever I would give a weather briefing or what's going on with the weather, is talking about highs and lows. So these are the big H's, those big L's. Let's first start off though with a quick review of air pressure. So basically, air pressure is just how much the weight of the air above you is pressing down on you. And in general, the number of molecules, the amount of air pressure decreases as you go up in the atmosphere. And that's basically just because there's less air above you. So here on the surface, we've got the whole atmosphere sitting above us as you sit there in class or sit at home. And then as you go up in the atmosphere, that air pressure decreases. That's why airplanes have to be pressurized, because they're flying up here at 34,000 feet, 40,000 feet, and the pressure is a lot lower. Where it's 1,000 millibars, 850 millibars, where we are down here, it's way lower in the 200s up where airplanes are. So that's why they have to be pressurized so that we can breathe and basically be comfortable in airplanes. Air pressure can change in two different ways. The main one is by adding or taking away air. So if you think about a balloon, as you blow into a balloon, you're adding air to it, and that's adding air pressure in the balloon. If you keep blowing and keep blowing, yes, the balloon will expand, but eventually the pressure will get too much and the balloon will pop. If you let air out of the balloon, you're taking that pressure away, and the pressure from the air around it pushes air out, and it deflates. The other method is by adding or subtracting temperature. If you add heat to a group of air, a parcel of air, it actually increases the pressure. It excites all of those molecules. The molecules start going crazy, and that starts pushing against the boundaries of that parcel of air, increases the pressure. Cooling it down slows those molecules down and decreases the pressure. That pressure change is important when we start talking about low pressure troughs and high pressure ridges. First though, let's really quickly talk about that big H and that big L. So high pressure, if we look at the diagrams here, high pressure is sinking air. So it's pulling all of that cool, dry air from aloft, from up in the atmosphere down to the surface. As that air gets pulled down, it actually warms as it gets closer to the surface. And it produces clockwise rotation at the lower levels. And because of all this sinking air, it actually prevents clouds from forming most of the time, and so it leads to few clouds and sunny skies. The opposite of that are low pressure systems. That you have air moving upwards, you have counterclockwise rotation at the lower levels that basically pulls in the air, forces it upward, and as the air rises, it cools and condenses, and that's why we get a lot of clouds around low pressure systems. That's often where we see a lot of the rain, because as that air rises, it cools, condenses, forms the clouds, and then forms the precipitation. So those are the big two features: the high pressure, fair weather, low pressure, stormy weather that we see across weather maps. Now, meteorologically, we talk about troughs and ridges, and that's because of how we look at weather maps. All of our weather maps, some of those that I showed you, are what we call constant pressure maps. So that 500 millibar map that I showed you in the weather briefing and that I'm going to show you again is all 500 millibars, all one pressure level. And as the pressure changes, as we get these highs and lows that move across it, the height changes of that pressure level. And so as we get the cooler air mass of those low pressure systems that comes across, remember what happens when we cool air is the pressure lowers. So we get what's called a pressure trough forming, where the height of that pressure level actually dips. So we get lower pressure, and so lower heights of a certain pressure. A ridge is warmer air, and again, when we excite air, we get a higher pressure, so high pressure, warmer air mass, and so that height of that one certain level rises. So think of this line here in the background as, let's say, 500 millibars, but as these low and high pressures move across it, the height of that surface changes. So up here becomes 500 millibars for a high pressure ridge, and a low pressure trough lowers the height of that pressure down into a trough. So The main thing to take away from all this is when you hear the words trough, think low pressure or bad weather. When you hear a ridge, it's a ridge of high pressure, which often means fair weather. So here's what they quickly look like on weather maps. You have the big ridge here. You get the big kind of hump mountain looking thing. So that's the ridge of high pressure with the low pressure trough behind it. So this one basically shows again that you get the mild and sunny skies with high pressures, a cooler kind of rainy weather with the low pressures. And so what this looks like again on the weather map, this is now the 500 millibar height map. So all you're looking at here is 500 millibars, and each of these lines is a height line. So here, this is a trough of low pressure, so this means that there are lower heights here for this one pressure level. So this is a low pressure system that moved across the southern United States this last week. You do have a ridge of high pressure behind it here. You actually have another ridge if you kind of see this little bit of a hump here. So there's a high pressure here. And then what we can do is we can confirm that on the surface map. So here you see the low pressure system that was over Texas, the high pressure that's over the Utah and Nevada area, and then that high pressure that was over the Great Lakes region. So that's what they look like on weather maps. That's a quick introduction to high pressure, low pressure, and low pressure troughs and high pressure ridges.